everything, but a lot, right? Okay, so yesterday we talked about a Ferris wheel, and remember, if it's a wheel, there's a certain things we know about this question, specifically that A is our radius, and that therefore we can also find the diameter. We know that D is the center of that wheel, right? That's like the axle for a car, right? The center of the tire. So keep that in mind. The period would actually tell us, depending on the situation, in this case, the x-axis is time, right? The period actually tells us how much time elapses for a full rotation to occur, right? So always keep in mind, like, what are the variables telling me? What's x, what's y? And so period, remember, is the horizontal distance for one full turn, right? So it used to be just x for us, and now it's time. It could be distance, you name it, days. Just pay attention to that. So we figured out that it takes 4 minutes for one full rotation. And so when does Tom reach the height of 40 feet for the first time? Let's enter this into our calculators first and foremost, because we're going to use it yet on the back side. We're not done yet. So if you could, oh, and I told you a little curveball here, right? You can be quite certain that I won't do that to you. But if I do, if I just feel like being rude and mean, I'm the Grinch, that's still Christmas, right? I will do that. But other than that, you need to worry about. So let's type that in, okay? So 20 sine, if this is correct, I need to change my window real quick. And I'm just going to say, I'm not too interested in the x min, so I'm just going to go -2 or something like that. X max, one cycle is 4 minutes. So I'm going to go like 2 cycles. That would be 8 minutes. I'm going to go up to 10 for the x max. The y min, I go as low as 5, so I'm going to go 3. And as high as 45, so I'm going to go 48 or 47, just above it. And there you have a nice graph. It's zoomed in. 2 full cycles are visible. Okay, so that should be your graph. When does Tom reach the height of 40 feet for the first time? And actually, this is tricky. This one is trickier than you think. All right. Let's draw. I think you all would agree that this is a y2 is equal to 40 situation, right? And so let's go ahead and figure that out. So y2 is equal to 40 feet. There's our line, no problem. When does the ride start on a Ferris wheel? Where would you start if you board it? The bottom, right? Unless you know something I don't know about Ferris wheels. You usually start at the bottom, right? So you know how this graph just goes, right? It repeats. We're going to focus in on here, on this point right there. We start there, and then you rise, right? And boom, it happens there. I'm going to focus on the time that elapsed between here and when you hit it the first time. And you're like, Mr. Jackson, could I start here and figure out the time it takes to get to there? Yeah, you could have. You might have some negatives, but they're going to end up giving you the same answer. You're going to have some double negatives, right? So I'm just going to focus on here, start here, go up to there. So allow me to give you a little sketch, as this is the best I can do here. I'm just going to try to make it look like that. So, okay. This is our y40. This is our 40 line. And we start here. Okay, that's where we start. Ride starts. Okay, and this is where we get to the 40 mark for the first time. Okay, reach 40 feet first time. If this graph would have been perfectly starting on the y-axis, this is a non-issue. this is not a problem. But because the nature of this question, you need to watch out for that. So let's go ahead and find the lowest here. We're going to go second, trace, min. Okay. Oops. Second, trace, minimum. I'm going to find the lowest. So I'm going to go left of it, enter, right of it, enter, enter. And that's 3.2866. 3.2866. And 5, right? No surprises there with that. And why you're using 4 decimals? Because you're going to have to subtract the times, right? So that should be given already, that you know that that's going to happen. And then I'm going to find the intersection. I'm going to go closer to this point there. Enter, enter, enter. And that is, this point right here is 4.826540. I wish I would have given you a bit more space here. Okay. So we're going to figure out delta time. Delta time would have been 4.82 dot 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 minus 3.28 dot dot dot. And that gives you, if you just follow my lead here, is 1.54 seconds. And I feel like I need to reword this question as well. You know how it says, when does he reach it the first time? I would say, how long does it take to reach 40 feet for the first time? That's more like it. How long does it take Tom, right? So I'm gonna scratch this part. How long does it take Tom to reach a height of 40 feet for the first time? I'm not gonna bother with the 2. I think you're gonna figure that out. And there's that. Okay. And I think I want to be a bit more specific, because when I ask you this, I want you to be specific with the period just before this. Okay. We're going to go to C here, and I'm just going to make very clear you understand. Time it takes. Time it takes for a full revolution. It's also acceptable to say how long it takes to go from the lowest point up to the highest and then back to the lowest point. If you want to say it that way, that's also acceptable. Okay, okay, let's graph, because we haven't done enough graphing. Yeah. You got me there. It's probably minutes. I'm reading it. I highlighted it up there, so that's minutes. Sorry. Please change it. Okay. It says graph 2 revolutions. So I think what I'm going to do here is I'm going to figure out the x scale. That is 4 divided by 4, so that's just 1 minute, right? I'm going to go up by 1 minute. I think all of you would agree that we start at the low point, right? So if you start at the low, you're going to go back to the mid. What's the mid? It's given to me by the equation. It's 25. Then to the highest. Then back to the mid. And back to the lowest. Okay. So this would be 1 full revolution. So you need another 4 points. And if you don't like this, that's fine, as long as the points are where they're supposed to be. So I go from the lowest back to the mid, back to the highest, mid, and the low. Okay. So I start, you gotta watch out here. When do I start at the lowest? I just actually figured it out right here. 3.28 or 29, right? 3.29 like this. And we're just gonna have to add 1 minute. So this is actually not that bad. So it's 4.29, 5.29, and so forth. And so I want you to be comfortable with not starting at a whole number, okay? You should be quite comfortable with that. So then you come over here and just put down time in minutes. Don't forget your units, right? And then you have height and feet, okay? And it looks like my scale needs to go all the way up to 12 or so minimum. So let's see here, 2, 4, 6, 8, 10. Not quite. Let's see here. 2. I'm going to make it work. It's 11 something, so I can make it work. Okay. And then for the height, I think if I go up 10, 20, 30, 40, yeah, that's going to work. So 10, 20, 30, 40, and then this is 50 here. Okay. Have a ruler. I would strongly encourage you to draw your 5. This would be 5 right in halfway. Five. Then it's 45. Then it's 25. There you go. There's your 3 lines you're going to jump in between. So 3.29, 5, that's where I start. So this is my 3 line. I'm just over a little past it. 3.29, this would be 5, 5.5, so 29 is right about there. Next one is 5.29 is right about there. And it's 6.29. And it's 7.29. 8.29. 9.29. 10.29 and 11.29. 11 would be about 2.5 boxes over, so right about there, 11.29. So I go like this. Smooth, okay, smooth transitions. There you go. And then we'll just make sure the equation is on there. Whichever one you prefer. We can do the rewritten one. There's your, that's 2 revolutions of the Ferris wheel graft. And we don't go into the negative y's in this case, but you know, it could be. There will be scenarios where you do. Like the paddle wheel on one of those boats, right, that goes below the surface of the water, you will have some negative heights there. So watch out for that. Right, I went +1, +1, so I'm just going up by the X scale. You need to have a calculator for the first point, right, and then just go with it. Yes. This is how some of your heads are going while you're trying to pay attention. Your eyes, this is your eyelids, right? You're like, right? So that's a That's 2 full cycles of how your eyelids are working right now. Okay, let's keep going. On page 20, there's more. Some of the nuances you need to be able to figure out. How long does it take Tom to stay at or above 30 feet during one revolution? So this is going to be actually interesting. So make sure you write this down. So y2 is equal to 30 feet, right? And we're going to go second, trace 5. But here you have options. You like options, don't you? Okay. 30 feet, graph it. And so the ride starts down here, right? Goes up and then back down. So technically, the difference in time between you get it to the first time and the second time, that's going to be it. That's going to determine the time. But I'll show you something else in a bit. So let's do that first. You want to do time 1 and then time 2. How about we do that? Second trace 5. It really wouldn't matter which wave you pick. It wouldn't matter, right? Like if you pick this one or this one out here, like the difference will be the same because of symmetry, right? So that's 4.4475. Gonna find the other side. 6.1258. Okay. No problem. I'll just find the difference in time. 6.12 minus 4.4, and that is, I get 1.68 minutes. Make sure it's in minutes, right? Don't want to get the wrong unit there. I think. So what if it asked, let's do this here. What if the question asked time below 30 feet? What if the question asked you something like that? What you would do there is you would go time period minus time above. That's one way of doing it, right? Like if you take in one full revolution, which is 4 minutes, minus, we just figured out the time above, right? That'd be 1.68. I'm just throwing this in there. It wasn't part of my notes, right? That's 2.32 minutes. This is time below, okay? So I don't know if that helps you. There are other ways of doing it. You could go right from the lowest to the first time you hit it, find that time, and then you figure out the other time. That's up to you how you want to do it. Maybe what I will do is this. Right? This is your 30 feet line. And so this, what you found there, is the time that went by above, right? And the other one is obviously below, right? Within one, this is within one cycle, right? But you could have also, you're still highlighting. So go ahead and highlight, that's important. I just want to give you one more. This might come in handy at times. You could have figured out, right? We already know our min. The first time you hit it up here, if you figure out this time here, right, how much time went by from here to here, you could just multiply that by 2, right? If you figure out from the lowest to that point, and then times this, the time you got here times 2, then you also get this other half instead of doing it this way. Up to you. I find this more efficient. a lot more efficient. Okay? So you figure out what you need to do there. What's the domain and range? What is the domain and range? Read carefully. Let's go back. Always go back and see, is there any indication that this thing ends? And it does say right here, I'm going to go green. Okay? The ride goes on for 5 revolutions, right? This will affect domain, right? Instead of going on to infinity, that would be probably my biggest nightmare, right? Being stuck on a Ferris wheel for unending amounts of time, right? So that is that's going to put a stop to your domain, right? So 5 revolutions, right? 5 revolutions. It will tell you that it's 4 minutes times 5 revolutions, right? So that means that there's a total of 20 minutes that will have gone by the time the ride is over. Okay? So this is the it tells you that we're starting at time. What time do we start at? 3 point. Can you help me out? Is it 3.2566? 3.28 or 3.29, right? Right here. So we're going from time 3.29 all the way to, if it's 20 minutes after that, right? So the ride starts here, and 20 minutes after that, that would be 23:29. Right? We add 20 minutes to that. And my range is simply from the lowest point to the highest point, right? Like that we established already, like the lowest and the highest. So we had to kind of chunk it, right? We're saying, hey, we start here and we add another 20 minutes. If this had started at time 0, which quite often is going to be the case, then it would have been 0 to 20, right? But it didn't start there. So for this particular equation, we're interested in this domain. Okay? This will picture or model the scenario. We're almost done, almost done. Just a couple more here to emphasize the point. Write an equation that would model a Ferris wheel that's higher off the ground. Higher off the ground. What would we change, A, B, C, or D? A would make it higher, but it would also make it lower. So we just want the whole wheel to be higher off the ground. This would be D. Remember, D tells us the midpoint, but it also tells it would also shift everything up. Right? So we're gonna increase D, right? We're gonna increase it. So y is equal to 20 sine of 1.57x minus, I just need to peek, oh, where's my calculator? And minus 0.45. We're going to go plus, what was it before? 25? Yeah. So we're going to go plus 35, right? So instead of being here, it's going to go higher off the ground. It's going to be here, right? Because the midline, right, it used to be 25 and now it's 35. So it actually raises the whole wheel up. A Ferris wheel that takes less time to complete a full revolution. What does that mean? It actually means a shorter period, right? And what do you change to affect the period? Which letter? A, B, C, or D? Which one? B. Yes, B. What do you need to do to B? Up or down? Think of this. Period is 2 pi over B, right? The bigger this is, the bigger this number is, the smaller your period will be. So we need to increase. And you're like, Mr. Erickson, seriously, that's too much for me. I can't handle it. You could just type in the exact same one. Let's say you have no idea. So you're just going to, for kicks, just going to go, hey, I'm going to make it as 2.57075, the second one. And I'm going to keep everything else the same. And graph them at the same time. See that second one? It happens quicker, right? It's turning faster. So we need to increase B. So all you need to do is, yeah, just write, I'm going to go 2.57x minus 0.45 plus 25. I'm going to keep the D untouched, right? But this is the one I changed. Okay. A Ferris wheel that would go 5 feet underground as part of the ride. Just to make it scarier. Okay. You have actually options here. Change D, right? You can change D or change A, because they don't give you a whole lot of other indication here. Come on, just one more. So I will, you can do y is equal to 20 sine 1.57 x minus 0.45. What would you do here for this to go 5 feet underground? Minus 5. If you put minus 5 here, then watch this. Your max is minus 5 plus 20. Don't write this down right now. Just watch. Min is minus 5 minus 20. So actually go negative 25 to 15, right? So this will go a bit too low. But just make sure the difference between these two is 5. Does that make sense? Like if you went, let's try something here. I'm going to bring this down 25. The lowest I get here, if I go 25 minus 20, gets you to 5, right? So if I go 25 minus 30, would that work? 25 minus 30. I think I'm making this a bit complicated here. I feel like there's an easier way of explaining this, but I might have to do this tomorrow again. But what I would do is I would keep this at 25 actually, and just turn this into a 30. Because if I go to get my min, I would go 25 minus 30, right? If I go 25 minus 30, I get that minus 5 that I want. Yeah, I feel like I did a terrible job at this, sorry. I was just thinking, as I was typing it, I know I can do this, but I didn't think it through how to explain it. But I hope it kind of makes sense. I'll redo it tomorrow. But when I go this minus the amplitude, I get to the minus 5. So I think changing A is your best option. You can also change D, but I will just keep it like that. Okay. Thank you guys. Hold on. Homework. Try at least 2 questions. This spans, right? There's a bunch of whole page questions. I would strongly encourage you to graph it if you can, but at least answer the questions without graphing, right? So you know how to do it. Have a good one, guys.